At the incident of the Big Bang, there should have been equal quantities of matter and antimatter, which annihilated, driving the Big Bang. So, by rights, we shouldn't be here.
Scientist and futurist Michio Kaku has made a shocking discovery. Oumuamua had just returned, and something weird is happening. Can this alien visitor reveal any secrets from beyond the stars? Do you think it could be evidence of alien life or technology? Experience the thrill of discovery with Kaku as he explores the galaxy in search of the answers to the mysteries surrounding Oumuamua. Get ready for an outing that will stretch your mind and make you wonder where the limits of the world really lie. An extraordinary declaration was made today by renowned physicist and futurist Dr. Michio Kaku, which has captured the interest of both the scientific community and the general public. During a news conference that took place at the illustrious Kaku Institute for Theoretical Physics, he disclosed that the interstellar object known as Oumuamua, which had through our solar system in 2017, was once again making its presence felt. In 2017, Oumuamua had made its way through our solar system. On the other hand, this time around, Dr. Kaku stressed that something astonishingly uncommon was taking place. Dr. Kaku began his presentation as the entire globe attentively listened by reviewing the first observation of Oumuamua, a cigar-shaped object with a mystery origin that eluded explanation using traditional methods. Its odd trajectory, coupled with an acceleration that could not be explained by gravitational forces alone, gave rise to rumors that it originated from somewhere other than Earth. Even though there was a lot of discussion about it, Oumuamua was eventually removed from the solar system, which resulted in a lot of questions being left unresolved. Now, Dr. Kaku has revealed data that seems to show that Oumuamua has returned, which presents a once-in-a-lifetime chance for scientific exploration. Researchers were able to identify a distinct but faint signature that resembled Oumuamua's features. This was accomplished by harnessing the combined strength of observatories located all around the world. The strange behavior that the object appeared to be displaying when it was once again traveling through the outskirts of our solar system appeared to have increased in intensity since the last time it was there. Dr. Kaku elaborated on a mysterious phenomenon that encircles Oumuamua's current track. An in-depth investigation conducted by astronomers and astrophysicists revealed that the object appears to be changing its journey, departing from the path that was expected due to the effect of an unknown factor. Dr. Kaku suggested that advanced technology or even interference from extraterrestrial beings could be possible explanations for the phenomenon, but he was careful to point out that additional research would be necessary to determine the precise nature of the force in question. Both the scientific community and the general public were shocked by the repercussions that such an exceptional event may have. Those who were there pondered the probable causes and reasons behind Oumuamua's reappearance, and their thoughts were filled with several questions. Were we observing the very first physical evidence of intelligent life that existed beyond our planet? It's possible that this mysterious object has the answers to some of the most pressing questions in modern physics and the history of great civilizations. The declaration made by Dr. Kaku served only to increase people's desire to gain more knowledge and spurred an urgent demand for greater research and observation. Dr. Kaku brought his talk to a close by highlighting the significance of international collaboration in the process of deciphering the enigmas surrounding Oumuamua. He placed a strong emphasis on the requirement for increased collaboration between astronomers, physicists, and SETI, organizations located all over the world. They might be able to solve the mystery of this alluring extraterrestrial guest by working together and employing cutting-edge technology such as cutting-edge telescopes, cutting-edge data analysis techniques, and cutting-edge technology. While the rest of the world was trying to come to terms with this paradigm-shifting revelation, the return of Oumuamua promised to transform humanity's perspective of the universe, our place in it, and the possibility of life existing elsewhere in the universe. Scientists and space explorers eagerly awaited the day when Oumuamua would finally divulge its well-held secrets. In the meantime, they prepared themselves for a journey into the unknown that had never been attempted before. What is Oumuamua? The discovery of Oumuamua, the first known interstellar object to travel through our solar system, presented astronomers and space researchers with an unprecedented opportunity to conduct research. This mysterious traveler came from beyond our own star neighborhood, and the information they provided was extremely helpful in gaining a better understanding of the characteristics of interstellar objects and the likelihood of extraterrestrial life. Oumuamua was first spotted by astronomers in October 2017 while utilizing the Pan-STARRS-1 telescope in Hawaii, and it didn't take long for the object to attract the interest of the scientific world. Because of its peculiar contours and course, there has been a lot of conjecture about where it came from and what it was designed to do. Oumuamua was greatly elongated in comparison to the ordinary celestial bodies due to its shape, which resembled a needle or a cigar and stretched for around 800 meters in length. Oumuamua, being an interstellar object, had most likely come from a faraway star system before arriving in our solar neighborhood. This may be deduced from the fact that it traveled across space. Its visit and departure were brief due to the fact that it swung by the sun at a breakneck speed and used the sun's gravitational pull to change its direction. Despite this, astronomers made the most of the opportunity to gather as much information as they could during the comet's brief visit. According to the observations, Oumuamua's reddish tint and its peculiar brightness changes were distinct from any other astronomical objects within our solar system that had been seen before. Because of its unusual features, scientists have hypothesized that it could be made of metals, minerals, and even organic materials to some extent. It was speculated that its exterior was covered in a substantial covering of rust-colored interstellar dust, which could have collected on it over the course of millions or even billions of years as it traversed the galaxy. In their investigation of Oumuamua, scientists utilized a wide variety of telescopes and other instruments in the hope of uncovering any hints that could explain the object's origin or makeup. Unfortunately, the little amount of time available and the fast closing distance made it difficult to capture a comprehensive amount of data. In spite of this, the information that was gathered offered tantalizing clues regarding the characteristics of the object. Because Oumuamua did not have a cometary coma or tail that could be observed, astronomers came to the conclusion that it was most likely an asteroid rather than a comet. The mystery that already surrounded its nature was further complicated by its peculiar appearance and the rolling motion it had. Some researchers hypothesized that Oumuamua was either a piece of a larger object that had been broken by strong gravitational forces or a leftover from the process of planet formation. Because to Oumuamua's visit, there has been a rush of interest and debate among the scientific community. This has fueled arguments regarding the probable ubiquity of interstellar objects and the requirement for improved observatories that are capable of detecting and describing them. The data that was acquired during its passage is still being studied by researchers in the hopes of learning more about the interstellar intruder and the mysteries it harbors. Even though the brief encounter between Oumuamua and our solar system left astronomers with more questions than answers, there is no denying that it was a significant step forward in the field of astronomy. It provided a timely reminder of the immensity of the cosmos and the unfathomable potential for exploration and discovery that lies beyond our immediate cosmic neighborhood. Oumuamua Shape. Oumuamua, the name given to the interstellar object that has attracted the interest of scientists and astronomers from all over the world, has a peculiar and intriguing appearance. It has a rocky, elongated shape that looks strikingly similar to a cigar, especially when viewed from above. This extraordinary quality distinguishes it apart from the comets and asteroids that orbit our Sun and sets it in its own unique category. The elongated shape of Oumuamua piqued the interest of astronomers and brought it under the microscope as it traveled across the cosmos. This strange visitor revealed a distinctively elongated body, stretching out like a cylindrical object, in contrast to the familiar spherical or irregular shapes observed in asteroids and comets. In their quest to solve the riddles surrounding the object's origin and nature, scientists came up with a wide variety of ideas and engaged in heated disputes about the object's shape. There has been speculation that Oumuamua is an interstellar spacecraft that is being piloted by a technologically advanced extraterrestrial race. However, the scientific community reached a consensus that a natural explanation was more likely to be accurate, pointing to the probability that Oumuamua was an interstellar asteroid or comet. In spite of the lack of a conclusive solution, the cigar-like elongated shape of Oumuamua continues to be a mystery quality that sets it apart from other astronomical objects that we have observed within our solar system. Because of its peculiar look, we are reminded of the vastness and variety of the universe, which encourages us to continue our quest for knowledge and exploration. Characteristics. During the course of the investigation, the object in issue displayed a number of odd traits. The findings demonstrated a noticeable acceleration that was not caused by gravitational forces, which is evidence that other forces are at work here. Outgassing is a phenomenon that can be a possible explanation for this unexpected behavior. Outgassing is the process by which gases that were contained within the structure of the object are released into space. These emissions may produce a force, which would move the object in a specific direction if it was applied. The influence of solar radiation pressure was taken into consideration as a further component that contributed. When the object is subjected to the powerful radiation that is emitted by the sun, it has the potential to experience a force that is both subtle and significant. Photons that are emitted by the sun have the potential to collide with the surface of the object, which would result in the transfer of momentum and the production of a non-gravitational acceleration. The combination of outgassing and the pressure from the sun's radiation provided possible explanations for the observed acceleration that was not caused by gravitational forces. It was important to do additional research and analysis in order to verify these theories and acquire a complete comprehension of the manner in which the thing behaves when it is in space. The pursuit of further data and measurements to shed light on this perplexing occurrence was enthusiastically pursued by scientists and researchers. The interstellar object known as Oumuamua, which attracted the interest of astronomers and space enthusiasts alike, turned out to be an intriguing subject of research. During the thorough examination of its properties, researchers found that Oumuamua had considerable changes in brightness, which differentiated it from regular comets and made it stand out from the crowd. In contrast to comets, which typically have a distinct coma, a cloud of gas and dust, and a tail as they approach the sun, Oumuamua did not appear to possess either of these characteristics. This further differentiated it from the behavior that is typically associated with cometary objects, because there was neither a coma nor a tail on it. The erratic variations in brightness that Oumuamua revealed left astronomers scratching their heads. The findings of the observation showed that its brightness changed by a significant amount as it rotated, which suggested that it had an unusual form or component makeup. This varying luminosity provided essential insights into the one-of-a-kind nature of the object, as well as prompted intriguing concerns regarding the genesis and makeup of the thing. Curiously, Oumuamua's peculiar properties posed a challenge to establish notions regarding interstellar objects. The pre-existing assumptions were forced to be reevaluated as a result of its elongated shape and the lack of conventional cometary characteristics. A number of hypotheses were proposed by the scientific community, including the potential that Oumuamua is an interstellar asteroid, or even an artificial item manufactured by extraterrestrial civilizations. Regardless of the final classification that is assigned to Oumuamua, the fact that it does not have a coma or tail, in addition to its peculiar brightness changes, distinguishes it from the comets that have been spotted in our solar system. These peculiar characteristics sparked the interest of the scientific community and sparked disputes among astronomers, which inspired additional inquiry and discovery of the mysteries surrounding this extrasolar guest. Size. Estimates of its size are all over the place, with some research putting its diameter at 320 feet and others putting it at 1/4 mile. A significant amount of time and energy has been invested by scientists and researchers in the pursuit of uncovering the secretive object's actual dimensions. Their investigations have led to a broad range of estimates, highlighting the difficulties associated with precisely measuring a body in the cosmos like this one. Studies have shown that the object has a diameter of approximately 100 meters, which places it on the larger end of the spectrum. These estimations are based on observations that were obtained using telescopes stationed on the ground as well as satellite images. Scientists have made an effort to determine the size of the object as well as its impact on the area that is surrounding it by doing a thorough analysis of the data that is currently accessible. However, other investigations provide figures that contradict one another, showing that the diameter could be as much as 1/4 mile. These calculations take into consideration a variety of elements, such as the gravitational influence that the object has on other celestial bodies in the area, as well as the data that is collected from space probes and telescopes. Researchers have been able to arrive at these more accurate size estimations by applying intricate mathematical models, as well as extrapolating from behaviors that have been observed. In spite of the fact that these studies have arrived at contradictory findings, one thing has become abundantly clear: calculating the precise size of this celestial body is a difficult endeavor. It is difficult to obtain precise measurements due to its great distance from Earth, its highly irregular shape, and the various inherent uncertainties it contains. Future research may be able to shed additional light on the true dimensions of this intriguing object as scientists continue to improve their methods and acquire more data. In the meantime, the various size estimations exist as a tribute to the continued scientific endeavor of comprehending the secrets that the universe possesses. Regardless of whether the object's diameter is closer to a quarter mile or 320 feet, the very existence of the object and the features it possesses continue to captivate the imaginations of researchers and space fans alike. Pan-STARRS 1. The groundbreaking discovery of Oumuamua was made possible in large part by the Pan-STARRS 1 telescope, which is located in Hawaii's picture-perfect natural settings. This extraordinary instrument afforded astronomers a one-of-a-kind advantage in their quest to fathom the mysteries of the cosmos by virtue of its wide-field optical design and lucky sighting amidst the clear skies. Both of these factors contributed to the device's fame. The Pan-STARRS 1 telescope, which was outfitted with cutting-edge technology and had an insatiable thirst for the exploration of the sky, diligently searched the heavens while keeping its watchful eyes set upon the wide expanse that was above it. Because of its wide-field optical construction, it was able to survey a larger section of the sky than many other types of telescopes, so providing a panoramic image of the intricate patterning of the cosmos. As a result of its location in Hawaii, the telescope was able to take advantage of the region's pleasant weather and extraordinarily clear skies. As it was perched on the peak of a mountain, it was safely removed from the light pollution and atmospheric disturbances that so frequently affect metropolitan observatories. The Pan-STARRS 1 telescope was given a significant advantage as a result of these ideal conditions, which enabled it to observe the furthest reaches of the universe with an unrivaled degree of clarity. In the midst of its constant observations, the Pan-STARRS 1 telescope became an essential component in the groundbreaking detection of Oumuamua, the mysterious interstellar object that passed our solar system. The discovery is considered to be one of the most significant scientific achievements in recent history. Once Oumuamua was in its field of view, the telescope was able to immediately detect its presence, which was extremely weak but mesmerizing. As a result of the wide-field optical design, this endeavor was successful in the sense that it was able to detect objects that were moving across the sky in a more diverse range of speeds and directions. In addition to the painstaking observations made by the Pan-STARRS 1 telescope, the clear skies of Hawaii made it possible for astronomers to collect critical information regarding Oumuamua. The path it took, the speed it traveled at, and the distinctive qualities it possessed were all painstakingly analyzed in an effort to get insight on this extrasolar visitor. The Pan-STARRS 1 telescope in Hawaii is a monument to human ingenuity and technological prowess, and it will go down in the annals of astronomical history as an important landmark. As a result of its broad-field optical design and fortunate location, it was able to decipher the mysteries surrounding Oumuamua, which increased our comprehension of the enormous cosmos that lies in front of us. The origin of the interstellar object known as Oumuamua, which has attracted the interest of scientists and space enthusiasts alike, is still a complete mystery. The odd traits and path it took have been painstakingly investigated by specialists, which has led to a variety of fascinating hypotheses. Although we do not yet have conclusive evidence to support this hypothesis, a popular notion postulates that Oumuamua could have been fragmented from a larger planetary body that originated in another solar system. The scientific community hypothesizes that Oumuamua is what's left over from a larger celestial body, potentially a planet or a moon, that was expelled from its original system as a result of gravitational interactions or other astronomical occurrences. Rogue planets and moons also known as interstellar wanderers, have been postulated to exist in the vastness of the cosmos. These wandering bodies have been given the names rogue planets and rogue moons. If Oumuamua did actually come from such a body, it would have set off on a protracted and solitary voyage across the cosmos, eventually coming into contact with the solar system in which we live. Some experts have proposed the intriguing idea that Oumuamua might not in fact be a naturally occurring item at all. This is another thought-provoking possibility. The possibility that it is an artifact fabricated by a civilization that exists beyond Earth has ignited heated debates and grabbed the imagination of many who are fascinated by the idea that there may be intelligent life in the universe beyond Earth. The quirks of Oumuamua Shape and its unusual acceleration patterns have sparked speculation regarding the possibility that it was manufactured by humans. This theory, however, is still very much in the realm of speculation, and there is no hard evidence to support it. In spite of significant scientific investigation, experts have not been able to unearth definitive answers regarding the nature and origin of Oumuamua. It is difficult to determine the exact origin of this extrasolar visitor due to the limited data that is currently accessible, as well as the distinctive qualities that are being displayed by this interstellar traveler. In order for scientists to obtain a deeper understanding, they continue to investigate novel lines of inquiry, conducting data investigations, and making use of sophisticated models in their quest to solve the mysteries surrounding Oumuamua. It is still hoped that one day we will have a better understanding of Oumuamua and the mysterious circumstances surrounding its birth, as humanity's knowledge of the universe continues to grow and technological advancements continue to be made. Until that time comes, the concept of an interstellar traveler will continue to captivate our collective imagination and serve as a reminder of the grandeur and undiscovered mysteries of the cosmos. A scarcity of things exists between the stars. If really Oumuamua was a hydrogen iceberg, or even if it was just some quirk of nature ejected from a planetary system like Borisov was, then certainly space should be filled with more of these visitors from far-off stars. Borisov was an object that was ejected from a planetary system. Are astronomers surprised by the fact that, other than Oumuamua and Borisov, we have not discovered any other interstellar interlopers? Astronomer Dave Jewett of the University of California, Los Angeles, who along with Jane Liu discovered the first Kuiper Belt object in 1992, predicted that there were somewhere in the range of 10,000 interstellar interlopers in our solar system at any one time when Oumuamua was discovered in 2017. His prediction was based on the likelihood of discovering Oumuamua when we did. Nevertheless, Jewett confesses that he was taken aback by how soon Borisov appeared following Oumuamua, and he is disappointed that we haven't had another one since. Formula for anything that could travel between the stars. Comets like Borisov that are known to go into interstellar space could be explained by this ejection process. On the other hand, Oumuamua was not at all like other objects. Instead of the shape of a lengthy shard, which was previously hypothesized to be it, it most likely took the form of a disc-like sliver that was flattened on one side. In the form of Arakoth, a Kuiper Belt object that was visited by the New Horizons mission of NASA on the first day of 2019, we have seen a body that has a shape that is somewhat comparable to this one. However, the majority of comets do not have a form like Arakoth or Oumuamua. In addition to this, Oumuamua lacked the characteristic coma of a comet, which is the atmosphere that surrounds the comet's primary body. Furthermore, its acceleration altered as though it were being pushed by outgassing that was typical of a comet, despite the fact that astronomers were unable to detect any outgassing from the comet. Aside from the non-traditional explanations that have been proposed, one of Laughlin's favorite hypotheses is the concept that Oumuamua was a lump of solid hydrogen ice. The only possible location for the formation of such an entity would be in the frigid center of an extremely thick cloud of molecular gas. These clouds, once they have been gravitationally destabilized, give birth to stars. Nevertheless, it is unknown whether or not they are cold enough to create a solid piece of hydrogen like Oumuamua. If the hydrogen ice theory were true, then all of Oumuamua's properties would be straightforwardly explained, Laughlin said. If the hydrogen ice theory were true. According to this hypothesis, Oumuamua began its life as a much larger object deep within a molecular cloud but has now shrunk considerably as a result of the passage of time. Laughlin likes to compare Oumuamua to a bar of soap, which begins its life as a solid block, but after being washed multiple times, shrinks down to the shape of a thin oblate sliver. The difficulty with this hypothesis is that it is very difficult to make the atmosphere cold enough such that molecular hydrogen freezes off quickly enough. The problem with this theory is that it is very hard to get the environment cold enough. The temperature at which molecular hydrogen experiences freezing is around 14 Kelvin, which translates to 14 degrees above absolute zero, or negative 434 degrees Fahrenheit. It is possible for the centers of molecular clouds to reach temperatures comparable to those found on Earth, but in order for the hydrogen to rapidly condense into a solid state, all of the parameters must be just right, and it is unclear how frequently such conditions occur. On the other hand, if they are frequent, then Oumuamua would have been something that was assembled before the formation of stars and planets in their cloud. The path that Oumuamua took through space before it arrived in our solar system is one piece of data that lends credence to this theory. Oumuamua would have been in the same position where a large molecular cloud would have been about to form the stars of the Carina moving group 45 million years ago, according to astronomers who have traced it back and figured out where it was 45 million years ago. If Oumuamua is usual, then that suggests that the average star has a Neptune-like planet, just like our solar system, and adding that there is observational data to corroborate this. If Oumuamua is typical, then that suggests that the average star has a Neptune-like planet. If Oumuamua is typical, the gravity of worlds similar to Neptune may have been responsible for clearing away ring-shaped gaps in many of these disks, which can be seen in many of the disks. Although this may not sound like a groundbreaking discovery, it is significant for astronomers who have been trying to assess how typical or atypical our solar system is in comparison to systems that revolve around other stars. Many of the gas giant exoplanets found too far are what are known as hot Jupiters and hot Neptunes, meaning that they have moved inward and are now orbiting their stars at extremely close distances. Since of their proximity to their star, these worlds are unable to launch small bodies into interstellar space, since the escape velocity at that distance is too high. These other systems with hot giant planets are significantly different from our own solar system, in which the innermost worlds are very small, rocky, and far away from the Sun. These other systems have hot giant planets. Oumuamua's return and the bizarre events taking place provide us a chance to expand our horizons and learn more about the universe. Michio Kaku's research encourages us to venture into the uncharted, a trip that could lead us to discover new dimensions in the universe and test our preconceived notions of the world. Hope you liked this video. Make sure to hit the like button and subscribe to our channel.